For letter E, honestly, both sides look kind of simple, so it really doesn't make a difference which side you do. The general strategy is probably going to be the same for either. I would suggest going back to the strategy of changing everything to sine and cosine. So I'm just going to focus just on the left side for this one. So I'm going to change the cosecant to 1 over sine, and I'm going to leave the sine of x alone for right now. And then on the right side, we're just going to leave it as cosine x times the cotangent of x. Now, that's just kind of going through and making sure identifying. That's the reciprocal identification, or reciprocal identity. From here, we've got a fraction minus something. So if we think about this as sine of over 1, if we multiply this second fraction by sine over sine, to get a common denominator, we can have 1 over sine of x minus sine squared of x over sine of x equal to cosine of x times the cotangent of x. So now that entire left side is just, that got a little messy, the entire left side is just in terms of sine of x, which is kind of nice. Now we can combine both of those into both fractions into one fraction, and it'll become 1 minus sine squared of x over sine of x equals, again, cosine of x times the cotangent of x. Now, 1 minus sine squared, we've dealt with that a little bit already. 1 minus sine squared is cosine squared of x over sine of x. That's just a version of the Pythagorean identity. And the right side still cosine of x times the cotangent of x. Now remember, our goal is to make the two sides equal to each other. So we have cosine squared of x over sine of x equal cosine of x times the cotangent of x. What I'm going to do to make it a little easier is I'm going to factor out one of the cosines of x from that numerator. And so we can make it the cosine of x times the cosine of x over cotangent of x. Sorry, thinking ahead. Wow. Cosine of x over sine of x equal to the cosine of x times the cotangent of x. Now that cosine of x over sine of x, using the quotient identity, is by definition the cotangent of x. So we end up with the cosine of x times the cotangent of x equals cosine of x times the cotangent of x. Again, that's a quotient identity. Now on that one, you'd pretty much do the same thing if you were solving for the other side. You just kind of undo the exact steps that I did, where you'd probably put cosine times cosine over sine squared and then just kind of break it down. It's really the same amount of work either way. Not saying it's easy, but I'm just saying it's about the same amount of work. For letter F, tangent squared over secant equals sine times tangent. I'm going to just break apart this a little bit. Let's make it, well, tangent squared divided by secant. Well, secant is 1 over cosine, so it's really tangent squared times cosine of x. Oops, sorry, not of x, of theta. Equals sine of theta times tangent of theta. So again, secant of x is equal to 1 over cosine, sorry, I keep saying x. Secant of theta equals 1 over cosine. So we're dividing by that fraction. In other words, we're multiplying by cosine over 1. From there, what we can do is we can start breaking this up into sine squared of theta over cosine squared of theta times cosine of theta. So I forgot to label this first one, sorry. We use the reciprocal identity. And now, for the second step here, changing tangent squared into sine squared over cosine squared, that's using another quotient identity. Now, with sine squared over cosine squared times cosine, hold on, pardon me, one of the cosines is going to cancel out because this is cosine over 1. So this is just going to end up being sine squared over cosine, I keep forgetting theta, sorry, equals sine of theta times the tangent of theta. So we just kind of reduced it a little bit. Now, similar to what we did in the previous one, we know we want sine all by itself, so let's factor out a sine from that fraction. So we have sine of theta times, when we factor it out from the numerator, you're just left with sine of theta over cosine of theta. And again, we're hoping that's equal to the sine of theta times the tangent of theta. Well, sine over cosine, by definition, is our tangent. So we end up with sine of theta times the tangent of theta equals the sine of theta times the tangent of theta. And again, we used another quotient identity there. Not quotient identity.